What's the purpose of a contactor?
Turn on off, and then turn on the condenser motors.
Yeah. And high voltage to the, it's just a switch, right? It's just a gate. So it's energizing our compressor. And what else?
Fan.
Yes, the fan. That's exactly right. That's all it is, just a switch. Just like if you flip the light switch on, you connect two wires, you allow electricity to pass. What happens when you flip the switch off?
Turns off.
Turns off, you disconnect the power. There's no flow of electrons, right? So it's on and off. So currently using your contactor, right? And one side closes, what's the other side usually do?
Only closed.
This side, yeah, it's always closed, always closed. So when this side opens, does anything stay running?
Yeah. Only that.
What's that?
Only the crankcase heater.
Crankcase heater, yes, exactly right. The crankcase heater. Boom, that crankcase heater is so very important because we want to keep the crankcase warm. Why do we want to keep the crankcase warm?
Keep liquid out of the compressor.
Yes, to keep the liquid out of the compressor. That's right, because what does liquid do to compressors?
Wash out the oil.
Yes, it will wash out the oil, but on startup, when that pressure drops, it will actually, all the liquid refrigerant wants to boil immediately, and as it boils, it turns from liquid to gas, and as it does, it carries with it other liquid refrigerant and oil, and then you get all of this foam action happening, and it gets up into the compressor, and then things break. We don't want broken stuff, do we?
No.
No, we don't. We don't. We want to make sure that that we don't have broken stuff. So the crankcase heater is a great component to protect that. One of the things I would like to see, I'm not saying that you have to do this or anything because I'm not part of that, but during the maintenance, one thing that I like to ohm out is the crankcase heater. It's a very commonly failed part. So I'm not, some people ohm out contactors and they're ohming out like everything. For me, the one thing I'm really looking at ohming out is the crankcase heater. Like that's really the only relevant way of checking that. So I would personally like to see that so that we could say, hey, if we have a bad crankcase heater, that's something we could offer the customer. Because if there was one thing I could say to upsell more than like all this stuff that everybody's upselling, it'd be a crankcase heater for me. It's a compressor protector. It saves the life of the compressor. Like it's a super easy thing. You put a little band around it, you wire it in. I mean, it's just like, uses very little electricity. Yes?
I thought a hard circuit was a compressor protector.
So the crankcase heater is super, super important. And if we wire the crankcase heater like this, when we have a crankcase heater like this, what happens when this switch opens? Nothing?
Well, there's.
Don't be scared, it's just us.
Yeah, nothing.
This is my last week, so you guys can say anything. I won't. It's not like I'm going to be like, oh man, Billy Bob over there said the wrong answer. It's like, it's just throw something out.
I mean, it kind of looks like you broke the circuit, so.
It does look like we broke the circuit. So I am no longer getting my 240 volts to the compressors. What's the compressor going to do?
Turn off.
Turn off, yeah. I'm not getting 240 volts to the fan, but what's the fan motor going to do?
Turn off.
Turn off. Is there still a path for electricity to flow?
Yeah.
Yes, where?
On the left or right side.
Just on this side?
I mean, it's connected to the winding of the crankcase.
It is. It's connected to the winding of the crankcase heater. Good. And then where?
Comes back on the other side.
Comes back to the other side. So now we're here. Then where? What?
To the crankcase heater.
Yes, the crankcase heater. That's exactly right. The crankcase heater. Yes. We're going through the crankcase heater, and then we come on. So we have now a complete electrical path. And if we look at the motor,
What resistance should it have?
that's a great question. I don't know.
It's going to be, so your typical crankcase heater is going to draw usually less than an amp.
So what would that add up to? That would be like, you're gonna, well, the math would be like 240 ohms, something like that. It's gonna be much higher than what you would ohm out a compressor. So it's gonna be, you're gonna measure an ohm path, but it's gonna be in the hundreds of ohms.
When it says OL, for sure bad.
Yeah.
So usually you get a resistance reading or OL.
Unless it's the type of crankcase heater that has a line thermostat in place. Because there are some that do connect to constant power at the bottom of the contactor. And if it has a line thermostat, if you just ohm across, you're gonna measure open if the line thermostat's open, right?
Right,
So
and-
you have to know what kind of crankcase heater you have.
Even some of these will also have a thermostat in line, so you have to make sure you're checking just the crankcase heater itself and not any of the switches that go in there. So now the electricity is able to flow. When this opens, it flows through the crankcase heater and it starts getting warm. But the electricity has to make a complete pass, so it comes back to the other side. It comes through the windings of the crankcase, which also helps keep the compressor warm. It's not enough. We have such a big voltage drop. It's not enough power so for it to actually run the motor. We just have electrons running through in a coil, which creates an inductive heater. And then we flow home on the opposite side. When this switch closes, what happens? Yes! When this closes, the crankcase heater's off, but it's still wired in. How's it off?
Oh, because there's no potential difference.
There's no potential difference. There's no voltage difference. There's no pressure difference on that. So if we think about pressure difference, I need a pressure difference to cause electricity to flow through that. And here, when this closes, there's no potential difference between this point and this point. So there's nothing to push or force or push electrons from one side to the other. So the crankcase heater is essentially off, and then we have the full power of the motor, and the motor's running. And then when I open this switch, what happens? I'm getting older, I can't hear. You gotta speak up, say it.
The potential's back.
Yes!
So now it comes
The
back.
potential's back, so now we're pushing electrons to the crankcase heater. We have a voltage drop, not enough voltage to run the motor, so we're just crankcase heater. So we're keeping that motor warm while the compressor's off, and when the compressor's running,
It's already warm.
it's already warm. We don't need to add crankcase heat when the compressor's running, so it's off. Now, on that same point, there's many different ways of wiring it. This is Carrier's most common way, but also some of these will have a switch right here. And so you gotta make sure that you're testing it past that switch. Otherwise, it's gonna show that, it's always gonna show OL. So making sure that we're actually ohming out the crankcase heater itself. Because they're down here at the bottom of the compressor, where all the leaves and water and everything else builds up in, they're notorious for shorting out, especially Train. Train ones, like, I think they come from the factory with a timer that they short out in a very short period of time. So, but the crankcase heater is a very, very, very important thing. And I know all the time people just bypass them, but they're so important for keeping the life of that compressor working. So what happens if I replace this contactor with a double pole contactor?
It doesn't work anymore.
It doesn't work anymore! Well, the compressor works still, but the crankcase heater doesn't because
You cut the return path.
we cut the return path. Exactly right.
Should
We
we have
cut the
jump
return path. So how, if I only had a double pole contactor, what could I do?
Jump the wire.
Drop a wire. Drop a wire? I don't have a wire.
No, jump
Still
the
didn't
wire.
work. Oh, jump a wire, yes! We can jump the wire. So we can put a jumper from this side over here to that side. And now we have a path for electricity to flow. So we essentially can take a double pole contactor and make it into a single pole contactor.
What size wire does it need to be, guys?
At least at 12 gauge.
At least a 10.
10?
Yeah, because again, like your compressor and your condenser fan, 30 amps, 30 amps is a number 10. Now you could argue that it needs to be the same size as whatever is actually incoming. There's some wiggle room in there, so I'm just gonna say at least 10 stranded copper wire, properly connected. It's
Although
kind
then the switch pulls in, it's going to share.
But for simplicity, just,
yeah, it's actually a good point. It's
electronically
only-
it has to be this, but
Yeah.
you gotta have room for air. You need a standard that's bigger wire would be better.
Yeah, because if the contact fails, like,
Yeah.
and the contact can't fail.
What's cool about this is you always have a spare contact. Like I've literally gone to places before and I'm able to this contact failed. I didn't have one. late at night, oh, let me just flip the contactor around, and then now I got a good set of contacts that's never been used, because these contacts will never be pitted because there was never any arcing on them. Now, I'm not saying that you should do that. I'm just saying that, you know, it's a nice little.
It's fine. The reason why we've always used double pole 40s is because they do last forever.
Yeah.
Unless you get ants in them. And so that's the reason we've always used it. But this issue of like not noticing, oh shoot, crankcase heater, this whole thing, that's the main reason why we're making the shift, but there's other reasons too.
So now we have the option of the SureSwitch. And it looks a little different, but it's essentially doing the very same thing as a pole and a half or single pole contactor, because one side is always connected, one side is broken. And the difference is, I've had people that really hated these just because they're so different, but we have over here, this is called this line 1, doesn't really matter, it's line 1. We got line 1. I should probably just follow the same. Yep, so line 1, line 2, so here we got line 1, line 2. So, I gotta make it simple. There we go. Now, all right, so line 1 is a solid bar, right? Solid bar. So line 1, right here in the center, you see that little symbol? It just goes through this little connection, then it goes right over, and then we have the other connection, and now this is T1. The same thing as this right here. It's just a little bar, right? Don't go to the bar during work, but after work, you get that little bar right there. Same connection, no difference. The other side, here we got line 2, we go through a switch. Just like we have a switch here. So this is essentially a what?
A single pole contact.
Single pole, pole and a half, depending on what you call it, who you talk to. Yes, it's only breaking one side. So if we have our crankcase heater on it, where would you wire your crankcase heater?
On the
If it was this style carrier.
line 2.
Line 2?
Line,
Both wires on line 2?
well, line 2 and T2.
So line 2 and T2, you think it should go there?
Yeah.
You guys agree with that? You're right! It goes right there because we need to be across that open switch. Open switch, open switch. We got 99 problems, but a switch ain't one, right? So this is a sure switch.
Well done, Ty.
So it's the same thing as a single pole contactor. It just looks different because they moved the terminals from being across to all the terminals down here on the bottom. So I love these switches, not just simply because of that, but because for one thing is ants. Talk about ants, where we in Texas have massive amounts of fire ants, and they love whatever the frequency, the arcing, the heat, whatever it is, they love contactors. And we go out all the time for ants in the contactor. And if you're washing a condenser and you're not paying attention, you get ants in your pants. So you don't want either one. Like, they're both bad. So what we can do is we put in these where we have the sine wave, and right here is the 0 volt point. So here, 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 the voltage is what?
0.
0. So what this is actually trying to do is it's closing these contacts at this point in the sine wave. When this contactor closes, what happens when this contactor closes?
Arc.
Arc, right? Right, 2 by 2, we get the arc. Now when this one closes, we end up with no arc, right? No arc, because it's closing at the 0 volts. So theoretically, this should last, the contacts in here should last forever. Theoretically, right? Because it's not arcing, it's not shorting those things out. But also, what's another compressor killer that you have? Oh, well, that's an open question. It's a long answer. Okay, so give you the answer. Short cycling. One of the things I hated about the Nest thermostat was when they would fail, it would turn the compressor on and off, 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 and it would kill the compressors. I've had so many people say they've had compressor failures because of the thermostat, or because of bad wiring, arcing, or even float switches when they don't wire them like you guys do here. In other places, they'll do the float switch, and as the fan's going on and off, it just on and off, on and off, on and off, and it kills compressors. Compressors need to have a certain amount of runtime. And if we bring that compressor on and off, that's a lot of inductive current through there, it's a lot of heat in the windings, you're gonna kill the compressor. So what this also does is have a time delay built into it. I like this because it's going to prevent that compressor from coming on and off, on and off, on and off. It's gonna have what we call an anti-short cycle switch in there. So it prevents that compressor coming on and off. At one point in time, I used to add time delays in it, but I used the wrong ones, and then when those would fail, it would cause the compressor to short cycle. It was a complete failure. I intended on doing good, but they've solved that with this, all built in together. Because it is part of the switch, it prevents the compressor from short cycling. So those are two really good things, plus it also has a little light in there. It's got a count, so you can actually find the compressor, how many times the compressor is cycling. It's pretty cool, but it doesn't fit every scenario. I love these, I really do. But sometimes this doesn't fit, because sometimes we have just enough wire for all of our motors and stuff on the top side, and just enough wire for our power coming in on the bottom side. So you still have to carry your other contactor. And I love, one of my favorite contactors is the 40 amp double pole contactor. But these make it simple as far as the crankcase heater goes, the wiring, the switch, the short cycle, the ants issue with the closing at the 0 volt side. So you have to make sure you have enough wire to reach. And where you mount it, sometimes you have to mount it up higher, sometimes you mount it a little lower. It takes a little bit longer to replace because you have to take these screws off. You have to mount the back plate first, then you have to put these screws on to mount the front plate. I love these contactors, but that doesn't fit every application. And once you get used to using them, it's pretty awesome. So if you got a customer, especially they have ants in the contactor, or they've had an issue with that, and you try to tell them, yeah, you need to get your yard person here to treat for the ants, because they always listen to your suggestions, right? Oh, you got that one? Cool, I want to meet that customer. No, so it's a really good way to say, hey, you still tell them about treating their ants, but it's another thing that can help prevent that. Now, it's not marketed as to protect it from ants, because ants can still get in there. They can still short pieces out because it's still electronics. It's just less likely. The crankcase heater is so important, guys. Like, it's like such a simple component that's so important. So let's give it the respect it deserves. Let's make sure we wired it to where it works. And there's lots of ways of wiring crankcase heaters. Look at the schematic on that unit. This is the carrier, which is, I see, the most common that you have here. But there's several other ways of wiring them. We want to make sure the crankcase heater is off and the compressor's on, and it's the crankcase heater's off, the compressor's on, and the crankcase heater's on, and the compressor is off.
But a couple other things that I want you to pay attention to on these. Like all contactors, this does have a torque spec on it, and that's the one thing that I noticed compared to some of the other ones is, like, you don't want to over tighten. You want to make sure that it's snug. But and when I was installing these, they're a little bit more finicky on the lugs, I've noticed. And so there is a torque spec on this. If you guys have never used a torque screwdriver, I actually went ahead and ordered all of you torque screwdrivers because it's the thing you should know about anyway. I know you're probably not going to use it every time, but at least use it a couple times so you get a sense of what the proper torque is. Almost every circuit breaker, really everything that you work with that has lugs on it will have a torque spec, and it's going to be in the inch pounds. Yeah, I was making sure inch pounds, not foot pounds. So that's an easy mistake you can make. Don't want to torquing down to foot pounds. The other thing, the brownout protection in these is probably the best thing. That's probably the thing I like the most, because even when we put in the Cool Guard, for example, that's not going to have brownout protection. It's still going to operate. I mean, I think that one actually does have something, but this is going to be another level of protection. And especially if you just have a regular surge protector in place, you're not getting brownout protection from that, and this helps provide that. So when are you going to use these? I don't think we're going to use this on every single case. If we are going to use it in every single case, we're going to. No. Yeah, we're still going to have regular contactors on your truck, but when you're doing a compressor, this is a great time. It's also a great option to provide to clients. Hey, now's a good time to put this in. It has some additional benefits, but especially when you're dealing with this crankcase heater situation. Okay. Any questions about that?
When we replace compressors, should our crankcase heater and this
Contactor be a part of our code?
Should be, yeah. The question is if it didn't already have one. But again, it doesn't hurt to put a crankcase heater in as long as you wire it right. But adding that does add a level of complexity. It adds another thing that you have to do. There are aftermarket crankcase heaters, factory crankcase heaters. Crankcase heaters are not that complicated. Now, the one thing I do want to mention about crankcase heaters is you do have to position it in the right place on the compressor. So even in terms of where the brake is on the crankcase heater, you want to think about that because in some cases with some compressors you have a seam and you don't want the actual crankcase heater to be over the seam. Am I saying this right? Is that right? I'm
It
trying to
seems
remember
right.
It seems right. So you do have to think about it. And again, going back to that installation instructions on the crankcase heater, it's going to give you that. So much stuff. I was telling my kids this a couple days ago because I said something, I don't know what it was, and they're like, man, how did you know that? It's like, I just read it. Like, I literally just read it, and then I repeated it to you. That's all I did. I've made a whole career of reading things and repeating it, and people think that I'm real smart. Hooray, I can read. So just remember that. If you are gonna, and again, this comes to us being guys, we don't want to read the instructions, and I don't care if you don't read the instructions in your own house. In fact, I encourage it. Just throw the instructions out and build your IKEA furniture however you want. But when you're at work and you're doing things for other people, you want to make sure it's actually going to work right for them. And you get out, and the first time you go to do one of these, don't just be like, oh, I remember I did the class, I remember I'm good. No, just take a picture of what was there before, open up the guide, read it. I always tell people, read the stuff on the side. It's amazing what you'll find out. The other really cool thing about this is the multi-voltage coil, and that does come in sometimes. So if you're, light commercial, you're working on refrigeration, and it might have a 240 volt coil, or it might be a 240 volt or even a 120 volt coil in some cases with pool heaters. There's cases where you'll see that. So it's good to have universal in that way.
Thanks for watching. If you're willing, give this video a thumbs up and drop us a comment. Don't forget to hit that bell icon to stay updated with all of our future videos. And as a quick reminder, HVAC School isn't just a YouTube channel. Dive deeper with us at our main website, hvacrschool.com. Curious for more knowledge on the go? We've got you covered. Tune into the HVAC School podcast, available on all your favorite podcast apps. And while you're at it, join our thriving Facebook group. Also, don't miss out on our free mobile applications available for both iPhone and Android. We're all about community. For techs, by techs.